Good evening, one and all gathered here. It's my pleasure to introduce the speaker, Mr.S.Arivumani Senior Manager, Civil Design, Tractable Engineering Pvt.Ltd, Gurgaon, Haryana. He has completed his UG in Civil Engineering from Adi Parashakti Engineering College, Melmarvatur, in the year 2006, and he has completed his MTech Structural Engineering in 2019 in Ratan Institute of Technology, Faridabad. He has worked in so many projects and has designed the components in some of the projects such as beer and powerhouse, dam and structural design of powerhouse, underground powerhouse, and also he prepared design and drawings for Checkweir, bus terminal and community center under smart city project. Totally he had about 13 years of experience. I request Arivumani sir to take over the session.
Thank you, ma'am. Thank you for introduction. Yeah, good evening, one and all. And it's very pleasure to see you all people to join this presentation today evening. Today the topic is on Basison Hydropower Engineering. First of all, I had, as Madam told us, not 13. I given a old resume to you. Now it's around 50 years experience on hydropower engineering. So most of the projects I had done in India, that most probably North India and Nepal, German, Philippines and Uganda. So I have some of the knowledge to share with you. What is the basis of hydropower engineering and what are the components are there and how to design and what is the basic need and what are the advantage of this hydropower engineering. So just I want to give an overall view of the hydropower engineering here. Let's go to the presentation now. First of all, we know what are the source to produce the electricity. There are two sources mainly, that is renewable energy and non-renewable energy. This heading may be seen by you in your engineering classes. And renewable energy, one is solar, tide, hydro, and wind, or these are comes under renewable energy. And in non-renewable energy, mostly this thermal energy, means made of coal or lignite. Using these things as a raw material, we are producing the electricity. So this will come under thermal energy and oil and gas power and nuclear energy. And these are all non-renewable energies. So luckily we are under renewable energy. Hydro power is a non-renewable energy. So next we will go to the principle of the hydropower engineering. See, this is the whatever you are seeing in the screen. This is the one small section of a project or a schematic thing which is a dam to powerhouse. This is simple to explain you what is a hydropower engineering here. Basic physics. See, the potential energy is converted into kinetic, and from kinetic to mechanic, and mechanical to electrical energy. It's a simple thing. So this water is stored in a dam or a weir or a barrage or maybe a pond, maybe a tank like that. It will be stored in the water will be stored at some respective height. From there, the water will be taken through an intake structure. This is just an opening of a pipe or tunnel. From here, the water will be taken inside, and this water will be taken inside through a penstock. Penstock means nothing but a pipe, a steel pipe. Normally, in older days, this penstock pipe will be made of concrete in the small head projects, but nowadays mostly they are using steel pipes. Why? Because the velocity here it will be more than 6 to 7 meters per second, which is very heavy. So that may erode your side walls of your penstock. So we are providing steel material here, and the 2A steam steel we are mostly providing. Nothing but head. Head is nothing but the fall of water from some respective height to a bottom height. This height will be measured as a head here. This is a technical word which we will use. So this water, this is the intake, and after that this penstock will be taken through, the water is taken through the penstock to a respective head, and after that below at a respective level, this again there will be an opening, MIB opening, main inlet valve opening. After that the water will be flowed through this wall to a turbine. So this turbine is nothing but a fan. There is two type of turbine maximum, that is impulse and reaction turbine. And impulse turbine example will be the Pelton wheel, and this A reaction turbine example will be Kaplan or Francis or bulk turbine. So these type of turbine are used to just rotate the water will be just rotate this turbine, and this turbine is connected to a shaft, and from the shaft at the top you can see there is a generator which is again connected to the shaft, and while it was rotating this will be in further that will also be rotated along with that. Then you know that the electricity is produced, and this is the basic thing which you already study in your mechanical engineering subject in civil engineer in our civil. And the main thing you can see, the to finalize the megawatt or to finalize how much capacity the machine or electricity produce, this will be mainly depend upon the discharge Q and height of fall. These two things is the main criteria to decide how much megawatt electricity you are going to produce. So I will just in next slide I will explain you how it will become. So these are the main thing, and in detail we are going to see what are the things. This is the dam or something water is stored. From there the intake was, this is called intake, and after that this is the gate to operate or close or open this valve here. Then after that this will be installed. In some project it will be installed. If a project having a dam and power house distance at around 10 meter or 5 kilometer or 20 kilometer distance, then this water will be taken through a tunnel or channel or pipe, and from there the penstock will be stored. This tunnel and the channel will have a mild slope, where we will have a velocity of only around 2 to 3 meter per second. So there only concrete lining will be given in the tunnel, and where we want to increase the head, increase the fall, at that area we will provide this penstock pipe. That also we will see in detail below. So this is the principle. Next, this is the hydropower calculation formula. This is the formula to calculate how much megawatt we are going to install our unit. So P is equal to P rho GH into efficiency. So P is the power, electricity power, and Q is the discharge which is going to be taken to that pipe or diverted into through the tunnel or pipe. And this density rho is the density of water. That's 1000 kg per meter cube. And G, this 9.1881 acceleration of gravity, that one. And H is, as I told, waterfall height or head as a technical word which we will tell. And this one next is efficiency. The efficiency ratio will be differ from 0.7 to 0.9 depending upon the turbine which we are using, whether we are using for Kaplan turbine or whether you are using Francis or Pelton. This depends upon that one. And also the generator efficiency. This is called combined efficiency. So that efficiency will be used, and by this one the power can be calculated. So what is the type of hydro project? What are the type of hydro project? How it will be defined? So mostly it can be defined as based on the head. One will be the high head, medium head, and low head. High head is for a high head project, maybe component may be different. But the main criteria is that we will use the turbine as Pelton wheel here, impulse turbine. And medium and low head, we will use Kaplan and Francis turbine, that is reaction turbine. And in detail, we will see in later slide, we will see what is the distinction of how we will distinguish this high, medium, and low head. And then installed capacity, again, based on installed capacity, there is large project, small project, and micro projects. Large projects means more than 100 megawatt will be a large project, and less than 100 megawatt will be the small project. It means less than 5, more than 5 and less than 100 will be small project, and less than 5 megawatt will be the micro projects. And the kilowatt, somewhere there will not be megawatt, only the kilowatt they will produce. That also will become under micro projects. And also location of power house. This also depends. Like below dam, we will keep some power house, the dam top power house, or somewhere in canal we will keep the power house. And surface power house means just above the surface. Underground will be mostly inside the hill. We will make a tunnel and to around 100 or 200 or 300 meter long tunnel, or maybe 1 kilometer long tunnel. We will put a tunnel, and inside the tunnel we will make a big cabin, a big factory building, means a power house building inside that one, and that will be an underground structure. From there we will have all this power house, transformer base, and the switchyard and everything. and only the water will come out through the tailless tunnel, one small tunnel. Otherwise, everything will be inside the hill. So this is underground project powerhouse, and semi-underground means most of the part. This is 50% of your building will be below your soil, and 50% of your structure, superstructure, will be above your soil. So this kind of structure is called semi-underground project, powerhouse. And then pump storage project. Whatever we've seen before in this another three topics, that is hydro project means this is pump storage project, this is hydro project. And the difference between these two is, here we will have a dam. I'll show this one. Here we are having a dam. From dam we are taking the water and drawing the water through a penstock, and we are running the turbine, and this water will be just the outfall. This is outfall. From here the water will be thrown back to the river, and it will go back to the river. That's all. It will come and it will rotate the machine, it will generate the electricity, and it will go back. But in the case of pump storage, what we will do, the water will, there will be upper reservoir and there will be lower reservoir. From here, what happened, the water will be drawn, and the turbine will be rotated, and the water will be thrown back to a downstream reservoir. And this will be done in peak time. At the peak time, the power will be generated, and in there will be non-peak time also will be there. So at that time, what we will do, we will just pump the water from here by using the same turbine as a pump mode. In pump mode, we pump this and we'll put back to the reservoir. So this may cause, while for example, if you are producing 100 megawatt in daytime, for pumping this one, it may require around 700 or 600 megawatt capacity to pump back the water to the reservoir or dam. So here we will save around 300 or 400 megawatt we will save, and sometime we will save this peak time demand. We will utilize that one. That's why for that kind of things, most probably nowadays they are going for pump storage also, and mostly in Andhra Pradesh they are doing that one. Because there is no water or river, we are having this kind of source perennial river, we are not having in south. So we are preparing a reservoir upstream, and we are providing another reservoir at the downstream, and we are pumping the water at the night time, and we are using the same water to generate the electricity at the day. So this is called pump storage projects. So now the another thing was, what are the components of the hydro projects? Mostly the civil, three categories we are dividing here. One is civil, hydromechanical, and electromechanical or electrical mechanical will tell. Civil, that means dam, tunnel, penstock support, power structures, tunneling, canal preparation, and else that slope protection, excavation. This everything will come under civil one. And in hydromechanical, we will like gates, penstock, and walls. This will become under this hydromechanical parts. And electrical mechanical, this will cover the generator wells and towers and other cabling and other things. This will come under electromechanical. So the main three division of engineering in civil, mechanical, and electrical will be involved in a hydropower project. And again, for I think these people, the people who are attending here are civil people, I think so. Madam, these people who are attending here are civil, no? Hello.
Yes, sir. Yes, sir.
Yes,
fully civil.
Yes.
Yeah. So it's very happy to again. Just I want to tell you another one happy thing. In hydropower, we will use all our civil engineering subject. From first year to the final year, you may study these subjects: survey, geology, geotechnical engineering, hydrology, hydraulics, rock mechanics, or structural engineering. After you are completing your Ptech, when you are going to the master's degree, those people will take a separate specialized subject. So this kind of subject like survey, in this 1, 2, 3, 4, 5, 6, 7, 8, 9, this subject, all the subjects are covered in our hydropower. Survey, we will do the survey also. After completing a survey, we want to check the geological condition of the rock and the location. And then we will go for the geotechnical engineering. We will just check out what are the C and pi value and what is the characters of soil and rock. Then after that, the people separate department, hydrology department, find out the probability of water, how much water can be utilized for preparation of our generation of this electricity. And then hydraulics, then how we want to prepare the structure shape, how much dia and what will be the shape and what will be the opening and what will be the height of dam and what will be the length of the penstock. This everything will become comes under hydraulics. So we will study the hydraulics or FEM, this one, fluid mechanics. Then after that we will go for rock mechanics. Most of the thing we will do the underground works, tunneling and underground powers and everything we will do. So these kind of rock supporting pieces and this thing will cover under rock mechanics. And main thing, and obviously structural engineering also we will cover it. So all other stuff comes under structural engineering. So in hydropower we will just look after this, all the things we will cover. So we will have all this kind of department. So all the people who are completing civil engineering have the opportunity in hydropower. And now we will concentrate on mostly on civil now. Civil, there will be two essential. One is essential, non-essential parts in civil components in hydropower projects. First, we will see the essential components of civil components. We will see here. One will be the diversion structure. Diversion structure is nothing but the dam. Mainly the common name is dam, or otherwise we can tell barrage, weir, trench weir, like that. This everything is a diversion structure which is used to divert the water. From a river, we will put a barrier, and then from that barrier we want to divert the water for our use, for our hydropower production use. So that we will put a dam there. So that's why it was called as diversion structure. Then after diversion structure, it comes water conductor system. It's nothing but wherever the water goes from the diversion structure to our to the end of the power house, where we have the turbine. So these things we will call it as water conductor system. The water carrying systems are called water conductor system. Channel, maybe tunnel, and maybe the pipes and stocks, such shaft. This everything will cover under water conductor system. Then comes to the power house. Power house is nothing but the housing of your turbine and generator, where the final output will come. So this is called power house. Everything will be there, like electro-mechanical equipments, control room, service bay, transformer bay, and everything will be enclosed in this power house. After the stainless channel is nothing but after the water was used by our turbine, those water want to be put back to our river. So that will be diverted through the tidal system. That may be a channel or tunnel. That also we will see in detail below. Now, diversion structure. This is the diversion structure. First one is dam. So these are the types of dam which you are seeing. There is more kind of dams. People may cross more type of dams in your life, like maybe in this one industrial visit, or while you are going for picnic, or while you are going out somewhere, you may see these kind of dams. And this is mostly divided into these kind of types, like concrete gravity, rock-fill dam, earthen dam, arch dam, and buttress dam. CFRD is concrete phased rock-fill dam. CC dam is roller compacted concrete dam, and the AFRD asphalt phased rock-fill dam. And more have been now introduced in the society, like steel phased also there, timber phased also there, and geomembrane phased rock-fill dam also there. This everything is depend upon the usage and depend upon the geological condition, and for what purpose we are going to use the project, and what is the height, and what will be the valley size, how it looks, and what is the rock stratum. This everything is depend upon to select the dam type. And in dam we will have this kind of this one, spillway. Spillway is nothing but to spill the water from the dam to the downstream. When we are using the water for the hydropower, we will have a tunnel and intake separately, and the excess water will be spilled out from the dam during the flood time, or if you not necessary you want to spill it out, then from upstream to downstream we will spill out the water. So these are the types of spillway: Ogi, chute, side channel, morning glory, tunnel, and under sluice. These everything are the type of spillway. I don't want to go in detail, that will be boring you. So next will be the diversion structure, like energy dissipator. These all comes under the dam only. Energy dissipator is nothing but from spillway, the water may be come in such a force or such a velocity that may disturb, or that may damage your downstream soil or rock in a year or in a 2 year, like that. So to stop that one, to reduce the force or to reduce the pressure from the water, we want to use some jump reducer. So for that we will put some stilling basin. Stilling basin is nothing but a type of swimming pool or pond we'll put at the downstream to slow down the pressure. Or step jump bucket is nothing but we will put a bucket so that it will rise the water to some height, and again from there it will come down, so that we will reduce some pressure. And roller bucket is nothing but while you are putting the water in between the slope, we will put some stopper to stop the force. So this kind of the energy dissipator are there. And this one is temporary diversion structure. This is nothing. Before starting my hydro project or before construction of any dam, there will be some much amount of water always flows in the dam. So what I want to do, I want to divert the water first. Otherwise, it is not possible to construct a structure, that means a concrete structure or rock fill structure. If I want to build a structure, it is not possible to do in a river flowing water. So what I want to do, I want to put some temporary diversion structure in the river to divert the river temporarily to do my work. So this is called as temporary diversion structure. So for the here, these are the things. Diversion channel may be used. Sometime we will put the tunnel to divert the water from my project area. And coffer dam. Coffer dam is nothing but a small type of dam to divert that water. I will put across the river, and I will stop the water, and I will make clean of my downstream to work, and I will divert this water through this channel or tunnel to the required length, and I will throw back to the river after some time, so that the in between area will be dry for and it will be used for my working purpose. Then, as I told, dam, and after that barrage. Most of the people we see barrage also in the roadside and everywhere. And common man will tell dam, everywhere they will use the dam word, or they will never use barrage and other things. Barrage and dam, the difference will be dam will be for certain height where we will have a capacity to store water. We can store water in dam, but in barrage it is not possible to store a water. It will be temporary storage only. Means the bottom, the sill level of the structure will be kept at the river, and whenever required, we will put a gate, we will close it, and we will store the water. And if you open the gate, and it will the water will be removed from there. But in the dam, it will not be like that. The gate will be at a higher level, and below that we will have our this one structure to stop the water that will store our water. This is the difference between the barrage and the dam. Here is nothing but a barrage only, but in barrage we will have a gate to close the water, but in weir it will not be there. Without the gate it will be there. That's why it is called weir. There are two types of weir. One is broad crested weir and trench weir. We will see the picture and other things in subsequent slide. So I told water conductor system. Water conductor system, as I explained before, this is an intake where the water will go inside, and after that head regulator where we will have the gate and other things. And then desilting basin. Desilting basin is nothing but the river will carry more silt, and we don't know what is the property of silt. So what we will do, we will have a laboratory check of the to check the capacity, to check the specification, and to check the quality of the silt, whether what kind of silt, what is the sharpness, and what will be the microns, and what will the quantity of silt carrying by water. This and all we will check it out. And we will design a desilting basin. Desilting basin is nothing but a tank. We will allow the water through the tank from intake to settle down. We will give some time to settle down that silt. So from one end, most probably this will be 100 or 200 or 300 meter long tank. We will flow from one side. We will flow through the water, and it will take another 10 or 15 minutes or half an hour to travel from one end to another end. So while it was traveling from here to there, it will get a settling time. That settling time will be used to settle that silt at the below of that coffer, so that it will be removed at the bottom. So why we are removing the silt means, if the silt is more, then my turbine wheel will be damaged quickly, and we want to change our turbine. Hello, yeah. There's any question? Okay, so that the turbine wheel will be damaged, it will be eroded by this silt, so it will be very costly to change also. So normally we will put this desilting basin or desilting chamber to remove this silt. This desilting basin is nothing but it will be an open tank, and desilting chamber is the same thing, but it will be in underground. That's all. This is the difference. And power channel. Power channel is nothing but from intake to desilting chamber, there will be a channel to carry the water. So it is a simple channel. So it will be called as power channel. Then water conductor system. This is the main thing. After the desilting basin, the water will be carried through a tunnel that is called headrest tunnel. This tunnel may be 1 kilometer long, 2 kilometer long, maybe 20 kilometer long also. That will be taken from the dam to the power house location. And there may be a cut and cover section also. Cut and cover section means this headrest tunnel will be in underground, and cut and cover may be in open area. We will make a trench, and we will make a rectangular section, or maybe a circular section will make, and then that will be closed. And there will be added is nothing but to build a HRT, this headrest tunnel for 2 or 4 kilometers or 5 kilometers. We will have only two phases. One will be in intake phase, and another will be in penstock area to enter into the tunnel to bore the tunnel. But that will take more time. So we will put some intermediate tunnel, small adit to approach this tunnel area to do the excavation. And to facilitate this excavation, we will have this adit at the intermediate portions. And 4-bay and sesh tank, I will explain you in below. It's a very important section. I will explain below that one. 4-bay, sesh tank, sesh shaft, and surface escape. This everything will cover the same thing that I will explain below. And water container system, again cross drainage. Somewhere what happened, the tunnel may not be longer inside that tunnel hill. In between we may see some cross drains like a river or a small nalla, something we will just to be crossing over through. At the time I want to cross that nalla through my aqueduct. Aqueduct is nothing by putting a bridge, a small steel bridge, and above that I'll take through a steel pipe. I will take through the water by one end to another end, or siphon aqueduct, super pass, leveling cross. This kind of types I use to cross my water from one end to another end. And penstock, as I explained before, that is penstock is a steel pipe which is carrying a water at high head with a velocity of more than 7 or like that. So this is called penstock. Penstock is nothing. Penstock and pressure shafts are same. Penstock is nothing but a pipe which is laid above the ground level. Pressure shaft is nothing but the same pipe which is put it at underground. These two differences, because in penstock we will not take the surrounding pressure. In pressure shaft we will take the surrounding pressures. That's the difference. That's why this typical name was given here. Otherwise, both are the steel pipe only. And at last, power house. Power house will be, as I told, surface, underground, semi-surface, and shaft power house will be there. And this is the overall dimension of the power house. How to finalize the length of the power house. To define the length, we want to keep the length of the service bay. Service bay is nothing but the area where we will keep our we will unload our turbines and other machines, and where we will repair the work or service our machines. That space is called service bay. And space required for crane to handling the last unit. So not the last bottom. If I have 2 or 3 unit, 4 unit, 5 unit machine, then last unit I want to have some space to clear space to handle my machines. So that is K plus wall thickness at the end, wall thickness, and number of units. Units is nothing but 1 unit is one machine. One machine is called 1 unit. That machine capacity may be 50 megawatt, 40 megawatt like that. Mostly power house will have a series of units like 2, 3, 4, 5 units like that. So this also want to be added. Multiplied with this one. So that will give the total length of your power house. Then tail race, as I told before, that is nothing but to flow through the water back to the river from the turbine. That is called tail race. That may be a channel or it may be a tunnel. And these two things we will use, channel or tunnel. And this outfall structure is nothing but after this channel or tunnel, we will have a small structure, concrete structure with a gate. During the flood time, the water in the river should not get back into the power house. So at the time we will put that gate. So this structure is called outfall structure. So non-essential civil structures are like log booms, logs, chutes, fish ladder, and infrastructure walls. Log booms is nothing but mostly in the Himalayan region, we will have a very high flood during this winter time, rainy season. At the time, this rain will this flood will take away this one booms like tree, wood, and other things. It will take away. That will come and stuck with your intake portion. So that won't be removed by some boom arm. So that is called log boom. That it is just like a crane. And log chute is nothing but again this is a type of spillway at the top spillway that is used to only used to remove the logs, this timber and these wooden parts want to be removed from there. That will be used through the chutes. That is called log chutes. Fish ladder. Nowadays, what happened, wherever if you build a dam or barrage or something, the environmental people, you want to get approved from the environmental people before you are constructing the power project. So those people will give this one. We want to provide a fish ladder there because the fish will be migrated from upstream of the dam to the downstream of the dam. So those people don't want to do that one. So those are giving a suggestion to pass the fish from the downstream to upstream. So whenever the fish comes from upstream to downstream, we want to provide this ladder so that the fish will be go back from the downstream to upstream using that ladder. And infrastructure works is nothing but apparent structure for this one, for dam and other things like guest house or office building and other things will be the infrastructure works. Then mechanical equipments are like gates, walls and penstocks. These are all mechanical things, like wherever we will provide gates, necessary gates we will provide radial, vertical, drum type, stop lock and bulkheads are the types of gate. And walls we will provide in the powerhouse and shaft area. Butterfly and spherical wall. Butterfly is used in low head projects and spherical is used in high head projects. And electromechanical components, these are the electromechanical components, just like turbine, scroll casing is nothing but the casing for the turbine, and draft tube is nothing but below the turbine to draft the water that will put in back to our, this is the connection, draft tube is the connection between the tail race and turbine. And generator, you know that one, shaft, that is generator will have the top, that is starter out and shaft, it will be there. Then electrical operating travel EOT crane, that EOT is nothing but a electrical overhead travel crane, that is very important to in all the powerhouse, just to have the repair work and services work in the powerhouse area. And main inlet valve is nothing but after the penstock, we will have one small valve to control the water flow into the turbine. That is called main inlet valve. Lighting is nothing, and here heating, ventilator, and air conditioner will be handled by electromechanical paper, and oil handling system also will be. This is a compact one. We will not have any tunnel or something. Just below that one, we will have whichever we seen the first slide. We had seen an example for the principal one. No, so same thing will be here. This is a section of the some type of power projects. See, this is the intake. From here the water drawn, and I kept my powerhouse here itself. Underground powerhouse. This is underground powerhouse. From here it comes. The power has been generated in this powerhouse area, and here the tail race is this much longer. So here, since the tail race tunnel is longer, so I am providing a surge tank here to remove the surge. So I am throwing my water back to the river. This is one type. This type you can see here, tunnel is long. Here the tunnel is long, tail race is short. So I am providing a surge tank at the upstream area, upstream of my powerhouse. There you can see downstream of the powerhouse I am providing the surge tank. Here I am providing same surge tank at the just upstream of my powerhouse. So this is the pressurized tunnel. From here the water will be pressurized and it will come here. And here this valve gallery, I will have the MIV valve. Whenever my machine is getting shut down, or there I have a short circuit or tripping is there. So immediately the gate will be, MIV valve will be closed. If my MIV valve closed, the water will be get back here. So this, since this is the pressure shaft is steel lined, so there is no problem. So it will not damage my steel liner here. But while it goes up, this is a longer tunnel, this will start damaging my tunnel lining. So to stop that one, this surge will be released through this tank. So this is the surge tank used here, and this is the tail race again. And this is another one. We are having two surge tank, because here tunnel is also long and tail is also long. So we are providing two surge tank. One is here and another is here. This is the powerhouse. And another here. Here there is no powerhouse. Here surge tank it is not required, because this length is very small. So from dam straight away we are taking the water, and here we are just, this is a air cushion chamber to release the air, and after that this will be the steel penstock, and then powerhouse will be there, and it will go to river dam. This is the principle of the surge tank. The water comes, pressure tunnel, and this is the penstock. So we will have 2, 3. There is hydrostatic level. Whatever the level we are maintaining at reservoir, the same level if it comes, that is called the hydraulic level, steady level. And then below that we will have a minimum surge also. And the top we will have upstage, that is unsteady upstage level. We will have this one. This comes while my machine is closed. And this is one of the this again it's the same thing. Using the turbine was shown. This you are seeing, this is the underground tank. It's just shown for the underground tank, and this is the surface tank. This is the reservoir. This is the penstock. From here the penstock comes. This is the penstock support, and here we are having the tank. Again it goes and it rotates the turbines. And this is again the same type with a downstream chamber also. It's on downside also. Okay, design aspect. We will cover dam, substank, power house, and how to select the turbine. We'll just have a overlook on that one. I don't want to trouble on that. Just I to give you an overlook on that one. Dams, we will have more type of dams. Like according to the use, we have storage dam, like gravity, rock fill, earth fill, arch, buttress. These things. I will give you the example with the picture at the below, so that it will be easy for you to understand. And diversion dam, like example like weir and barrage, and detention dam like dike, water spreading dam, debris dam like that. And hydraulic design, overflow dam, spillway, non-overflow, gravity dam. These are all the types. According to the material also we will divide, like steel, timber, buttress. These things also we will divide. These are the classification of the dam. Selection of the dam. As I told before I'm selecting a dam, I want to have a detailed study on the project, how the topography is there, what is my foundation, site for the spillway is available or available of material, and what is my catchment area, storage capacity, and water tightness of the reservoir, sedimentation, silt content, communication, and locality, surrounding, length and height of the dam, life of the dam, roadway. This everything want to be taken into consideration before constructing a dam. These are the study which we want to done before. And the selection of the dam, again, arch dam is a type of dam that can be selected where we have a narrow V gauge value, where my value is like V, and gravity is moderate V. On rockfill, if I'm not having my distance between both the valley, both the abutment is around a kilometer or 200, 300 meters like that. When my valley is wider, then we will go for rockfill dam. Like Sathnur and other dam, we can see there, that is rockfill dam. There, between both the hill, we will have that valley. We will have around 400 to 500 meter long. So we will use the rockfill dam. Then geological and foundation conditions also will decide my type of dam. Rock foundation, any type of dam we can provide, but gravel and horse means only earth and rock fill dam, because that is flexible type. Fine sand density means then the earth and dam want to be there. Clay foundation not suitable. If clay material is found, just abandon that location. It is not possible to provide any dam there. The concrete gravity. What is meant by concrete gravity dam? It's nothing. A dam constructed of concrete or masonry. Okay, there is that bone weight for stability is called gravity dam. It will be stand on the bone weight, and whatever the force which acts on is upstream or downstream, that will be taken there by its own gravity, self gravity. That is called concrete gravity dam. Components of gravity dam is nothing: foundation on non-overflow section, drainage gallery, undersluice, intake gates, silt execution, and hoist arrangement, bridge, and instrumentation, other things. These are all the components. Assumption made while establishing the stability of gravity dam is that you can see dam is made of the individual transverse element, each of which carries its load to the foundation without transfer of load to the adjacent block. The dam, each and every gravity dam will have 20 or 25 meter long only. After that, we will have a joint. So one dam block want to take its own load, and it want to transfer its load to the bottom of the foundation. And it was designed that this dam body, this block, should not transfer the load to the adjacent block. So this will be designed like that only. And the vertical stress varies linearly from upstream phase to downstream phase on any horizontal section. Okay, so stress variation will be like this: from upstream phase to downstream, it will be vary. So this is a basic principle. And the requirement for stability is this one. Again, safety against sliding, then safety against overturning, and the stress of the dam at the foundation, and foundation material should not exceed the permissible stress which was given in the code. Force. What are the force consider for the stability analysis reservoir and tailwater load. Reservoir is water load and upstream. Tailwater load is the just downstream after the dam. There will be water, that tailwater level. Uplift pressure, which is below the dam, there will be a uplift pressure due to the head of the water at the upstream. There may be uplift pressure which may lift your dam from the bottom of the foundation. So that is called uplift pressure. Earthquake. Then earth and silt pressure, due to there may be silt deposit at the dam, so that pressure also want to be taken. Dead load of the dam. Ice pressure if it is there available, and then wind pressure. Wind pressure will not majorly affect your dam, but wind pressure will affect your wave action of the water, and as well as the superstructure like what is a control room and other things above the dam. And wave pressure, as I told, that wind that depend upon the wind calculation only, and thermal load, temperature variation. These are the just load combinations: construction load, operation, normal operation, flood discharge load, and drain in inoperative and drains in inoperative. These are the conditions. These are load combination normally we will use for the dam stability analysis. Then we will just see for the surge tank. Surge tank, what is the function of the surge tank? This just to reduce water hammer pressure. Okay, and reduces conduit length subject to the water hammer, and improves the stability and turbine governance. It acts as a small reservoir which can accept the reduced discharge and also meet the immediate requirement of the water. And type of the surge tank, according to the material of the construction, according to the location related to terrain, according to the location related to the powerhouse, according to the hydraulic design, and the special surge tank like air cushion chamber. This everything we seen in picture before. And according to the material, that is one is concrete surge tank and another is steel surge tank, the material which we used for the surge tank. And one will be the excavated underground and one is freestanding. These also we have seen in the picture. According to the location, one is upstream and downstream. That also I explained you before. According to the hydraulic design, again there is the simple surge tank, restricted orifice, a differential surge tank with the expansion chamber, and multiple surge tanks. These are some type of surge tanks which may be used according to your specification of the project and specificity of the surge analysis which you are making. We want to make a surge analysis before doing that. That will decide this criteria what we want to use. And this is underground open at the top and underground cylindric cavity chamber. These are the types again divided into this one. Restricted orifice is another type. This type of or modified a simple surge tank only, which with an orifice of an considerably smaller diameter installed between the surge tank and the conduit. Okay, so whenever I have a very high head. So at the time, what happened? To release my head, I surge tank dies, and there may be an area constrained at the surge tank area to build up that much big area, a diameter to build a surge tank. So to restrict that one, we will have a smaller restrict orifice we will have to release the pressure. That is called restricted orifice surge tank, involved in considerable head loss due to the throttling and maximum minimum surge level by damping of the surge oscillation. Differential surge tank. This is again, in addition, internal rising pipe will be given in between the outer and inner dia. Factor affecting the layout of the surge tank: vary component of water conductor system, discharge through the water conductor system. Water conductor system is nothing, as I told, tunnel. Transit flow condition in the water conductor system, length of water conductor system, turbo generator and relief valve mechanism, and ground topology and geology. And design considers of the surge tank, it should be hydraulic and mechanically stable. Okay, location of the surge tank, and damping of load variation in the power system, maximum and minimum surge which governs the surge tank height, and the topography obviously, and avoid lining. There is a provision to avoid lining due to pressure variation, because in surge tank always the pressure, the height of the water will be vary from one level to another level. So there is continuous variation. So due to that there will be erosion. So we want to give a high grade concrete there. And design condition, so maximum upsurge level of, and for minimum upsurge only we will design the tank. Then deciding the powerhouse layout. Depending upon the geology and other things, we will decide if the surface powerhouse or underground powerhouse or semi-underground. If I have enough space and good rock and good geology, if I have, so I will go for surface powerhouse. And if I'm not having anything, and if everything is a riverborne material or overburden material in the river, so that is very difficult for me to make a big powerhouse, and I will not get a good foundation rock below the soil to place my machines. So at the time I will go for the underground powerhouse, entirely underground. I will make a tunnel for around 300 meter long, and inside the tunnel I will put my powerhouse there. Semi underground is nothing but normally in Francis turbine, half of the turbine will be submerged, so it will be always in the water. So that means below the river level. So below the river level, I will have a protection wall, and I will put all my equipments below that one. And above the river level, I will have a normal RCD structure where I will have the crane support and other things. So this is called semi underground. And factors influence the layout of the hydropower section is civil engineering consideration, dimension and design electrical mechanical equipment and accessories, requirements of space clearance, area and efficient operation and maintenance of the power station. Powerhouse main things are machine hall, where we will have the machines, the turbine and generator. This is called machine hall. Erection or service way, that is nothing but, as I told, where we will erect our equipments there, and the machine is there, and whenever machine comes through the truck or something, I will unload there. Everything will be done in service way. Control room, where we'll have all controls, control panels, and this SCADA and cabling and everything will be there, and that will all consider control. And machine hall, as I told, main substructure. There are 3 structures in machine hall. One is substructure. This is mainly consists of the foundation, draft tube, elbow, cone, and other things. Intermediate structure is nothing but where we'll have the turbine spiral case and that foundation, stator, rotor, and everything. Superstructure, where I will have the column and roof and beams, where I have to support the EOT cranes, and other things will be the superstructure. Selection of type of turbine. How to select the turbine? Yes. As I told before, there are high head, low head, and medium head. This is Pelton wheel. This is high head turbine. Wherever I am having waterfall for around 300 meter high or above that one, then I will go for Pelton wheel. Pelton wheel nothing but like this fire engine, where we will have this jet at the end of that one. We'll have a jet, the pipe. That same type of jet will have a series of jet. Will have through the jet, this will be flowed to rotate the wheel. So that is called Pelton wheel. So the governing will be the center line of that pipe. So here that will be the governing line for the head. From 18 to 300 meter, that is called medium head. There we use Francis turbine. Here the water will not be flow through the jet. Here the turbine will be submerged in the water. Always that will submerge in the water, and the water will which I shown before. Whatever the example I shown in the principal diagram, there it will be always submerged in the water itself. So those kind of reaction turbine is called the Francis turbine. So here 18 to 300 meter head will be used, and less than 18 meter or less than this one, we will go for couple-on turbine. Couple-on turbine, the turbine blade will be somewhat different between these two. Otherwise, these both are called impulse turbine only. Sorry, reaction turbine only. These are the factors affecting the selection of the turbine. Turbine speed, less space, or a higher running speed. Hydraulic Francis turbine is more favorable because it can utilize the head down to lowest tail water level, whereas impulse turbine has to set up with a clearance of the few meters above the tail water level. Because of lowering setting, Francis turbine requires more excavation works. Francis turbine involves essentially dismantling for replacing of worn out laminate or runners, guidelines, etc. Whereas replacement is easy in case of impulse turbine. These are some kind of factors we want to decide which type of turbine we want to use, whether it is feasible for you, whether it is economical for you, and whether it is okay to select for your project. And these are the preliminary dimensional calculation for that powerhouse. How to calculate so that the turbine size, spiral case size, draft tube size, height of the lifting of the generator, and other things. These are everything factors affect your finalization of the dimension of a powerhouse. So the basic data which required in a hydropower is maximum water level, that will tell us MW level. This is a maximum water level that will be available in your dam. Above that, there will not be any level, because that will be calculated by using the hydrology method. So this is the maximum water level where the water will be go. Above that, the water will not be go. for your dam. Full reservoir is the reservoir level where the water is used for the operating of your machine. Full reservoir level in the reservoir, up to that only will go for your operation of your machine. Minimum drawdown is the minimum level of your water used for the used at the dam to our generation of the machine. Below that, if you go, then there will be interrupt of air into the intake. Average tailwater level is just below the transit. This tailwater minimum average tailwater level, these are used in the Francis turbine and Kaplan turbine, not in the Pelton wheel, because this is the controlling system to for your head. And average altitude of the site, maximum temperature of the water. This is also be what we cautious in, because some of the projects which I done in Himachal Pradesh, 4 or 2 to 3 months the project will not run, because the upstream of the dam will be freezed and everything will be ice at the time. So 2 or 3 months I want to shut down my project. So maximum temperature of the water and minimum temperature of the water is very much this one essential factor to decide about the project. And number of the units to be installed, how much total anticipated installing capacity we want to calculate by using power potential study. Restriction regarding setting of the turbine, because I may be positive or negative setting that we want to keep for the turbine. These are not factors which is basically needed. And definition, what is a maximum head? The maximum head is defined as a difference between the maximum reservoir level without spillway discharge and minimum tailwater level with one unit operating detecting the head loss. Okay, and the minimum head is the difference between the minimum drawdown level and the minimum tailwater level. And design head, the design head is defined as the head at which the peak efficiency of the turbine is developed at a rated speed and is calculated as under. Okay, 2/3 of the maximum head minus minimum head plus minimum head. This will give the design head. Okay, so mostly whatever just I want to tell you the overall view that I have given. Now I will see some of the projects layout and other photos which we have crossed. These are all the NHPC projects. See, this is a Chamera project. This is in Himachal, which you can see. This is the dam. Sorry, this is the dam. And from here, this is the headless tunnel. And here, this is the powerhouse. And from here, it's a tail case. And this is the river layout of that one. Next one, this is Uri. And again, this Uri, this is in Jammu and Kashmir. This is a layout, same like this is the layout of that one. And next here, this is the Rangi, it's in Sikkim, it's the same river. We are taking the water from Deer Dam, and this is the powerhouse location. And this you can see, this is the Asaf road, which is for the project. This is another layout of a Dhwali Ganga, it's in Uttarakhand. And you can see here also, this is the intake TCT chamber and entrance. And this is the intermediary, as I told before. This is the intermediary because this is the length of the tunnel from here to here. It's around 20 kilometers. If it is 20 kilometers, if I want to excavate, it will take more time. So one person will start excavating from here. Another team will start working from here. So I will put an intermediate adit wherever possible, and I will have another 2 phases to excavate. So these are all intermediate adit. And this is the Tista hydropower plant in Sikkim again. This is the intake, and this is the powerhouse, and this what I was saying, this is the HRT. And here the length of the tunnel is very long, so we are provided 2 adit here. And this is Parvati. Again, this is also in this is in Himachal Pradesh. This is one of the biggest project. So the photographs we can see. This is the river diversion works in Tegri. Tegri is the largest pump storage project as well as largest rockfill dam in India. So this is the river diversion work for the Tegri which was done, and the project was taken around 16 to 17 years to construct this project. And this is the earthen dam with concrete spillway. Here you can see this is the earthen dam, and but spillway will be in concrete, and this is the powerhouse. This is the another example for an arch dam. This is an arch dam, concrete arch dam. And yeah, I think some disturbance is coming. You can make yourself mute, please. Yeah, this is the rockfill dam. This is the rockfill dam. You can see this is the impervious core. And imperial core is nothing but this will be made of clay or butternut material. This is the upstream portion and this is the downstream portion. So these are all the rock fill material and this is the transition material which you can see. From here the water will not be transferred through this one because we are having a core, clay core here. This will be very cheapest clay core, and this type of material is called rock fill dam. Most of our old projects are old dams which are having in India are made by rock fill only or earthen fill. And this is the type of buttress dam. Buttress dam is nothing but, see, you can see a concrete arch here, but this will be supported at the downstream, not at the upstream. Normally dam will be we will have a this concrete gravity dam. We will have a dam and it will be full of moss concrete, but here it is not a moss concrete. You can see this is a thin wall and the thin wall is supported by a retaining structure at the down. This is called buttress dam. And this is the A40 dam, that is asphalt face rock fill dam. So this is asphalt material. Asphalt material is nothing but the material which we are putting for this road construction. The same material nowadays they are using and they are putting experiment for making this kind of thing. In the dam body rock fill they will make, and above that they will make it sealing by asphalt concrete. And this is a barrage. As I told, dam is different and barrage is different. Barrage, you can see this is the water level or riverbed level. From riverbed level itself, we will have the sill level. So water will flow here, and there will not be any storage. Only the gate we will have. Only while we close the gate, then water will be stored for the enough time. And if you open, then it will be closed again. This is a temporary storage time. This is again weir. This is called weir. Weir is nothing but a ungated weir, barrage I told. So there will not be any gate. Just the water will be stored and it will be temporarily stored and it will be overflow and it will go. This is called weir. And this is the trench weir. We can't see a weir here. This is a trench weir. There will be upstream water will come and water will come from the upstream. We will have a trench here and the trench will be closed with some steel meshes. So that the debris, you can see, the debris will not go inside the trench, and we will have a channel below. This debris will be stopped above, and the only water will be go below. From there, we will take the channel to here. This is the intake. From here, I will take the channel or tunnel into the powerhouse. So this is the trench weir type, and this is again an arch dam, China, for example. And this is the rock fill dam, purely rock fill dam. And this is inside the powerhouse. This is underground powerhouse. This is not surface. This is under the hill, underground powerhouse, Tehri powerhouse. And these photos we already seen before. This is again a arch dam. This is also Idiki in Kerala arch dam. And this is the concrete face construction within Jolly Ganga project. See, in between we are having a rock fill, just a fill, compacted fill. Above that we are providing the upstream. We are providing a concrete face. That's all. This kind of dam is called CF40 type. And this is the RCC. RCC is nothing but the methodology of dam will be somewhat different. But we will use concrete. The methodology will be different. We will pour the concrete. We will pour a dry concrete. Here the concrete will not be wet. We will pour a dry concrete and it will be compacted. Roller compacted cement. That's all. We'll pour the concrete and then we will just roll on that. So we will prepare the dam. This is RCC type dam. And this is again a buttress type dam. This is earthen dam type. This Tegri dam spillway. This one. This is a spillway. This is the aqueduct or siphon which we used from one project to one side to another side. It will be carried through a open channel. And this is the fish ladder. You can see this is the fish ladder. So from downstream to upstream, we will allow some gap. This one you can see. This one you can see. There is some type of step systems will be there that will be allowed, so that the fish will be passed through this one. It is designed like the fish will be passed through this water and will come down. This is the power intake where the water will go inside the water tunnel. Okay, so this is the main power intake which will have a main gate here. This is the trash track portion where the trash will be stopped here, and after that pure water will be get inside, and this is the main gate, service gate we will tell, and after that this is the stop lock gate. Whenever this is the service gate and this is the stop lock gate. Whenever this gate is repaired, then we will put the stop lock to repair this gate, and after that the water will go inside. This is a picture of this is the Tegri intake. You can see this is the Tegri intake. This is the intake of Tegri. This portion, water of the vertical portion which you are seeing, this is the trash act. So this is the trash track. After that, the concrete structure starts. These are all the intake. After that, it was tunnel. It was going inside the hill, and the project, the whole power house is inside the hill. And this is a desilting basin picture. This is a desilting basin. How the water will be settled, where we will allow our water to settle. And this is in surface sluice type in Metro Dam. And this is the tunnel, Apajaki tunnel. This is the tunnel where the water will be. This is the excavator tunnel. After that, we will put lining on this one, and it will be finished. And again, this is a tunnel where we are having a bifurcation. One single tunnel is coming, and one is going to one unit, another is going to another unit. This is a bifurcation part. And this is a rock support which is going on at the site, making a tunnel. And to have initial support, we'll put a rock bolts, steel rock bolts, and we'll put a shotcrete also. Shotcrete I'll show here. This is a shotcrete. This is nothing but a wet slurry type of concrete, which will be sprayed in the surface of the tunnel to hold it. And it will be done immediately, and curing time is also very less, so that it will be sprayed. And mostly we will put some wire mesh on that, and then we will spray on that for the initial support. This you can see, this kind of seepage may occur while we are excavating. Seepage inside, this is the flow of water inside the tunnel. Maybe 1 or 2 kilometers after we are going inside, this kind of seepage will be there. We want to divert it also, or we want to put some drains with a non-return wall. And these are the procedure for drilling jumbo. They are drilling, how they are drilling it for making the magazine, to put the magazine blasting material for the tunneling. And this, TBM, this is tunnel boring machine. Nowadays, these tunnel boring machines are used in the large projects where we have 2,000 megawatt or 4,000 megawatt, because purchasing this machine itself is a costlier one. So we are going for tunnel boring is somewhat costlier effect. For big projects like NHPC, or these people will use this machine. But the only one disadvantage is, if this machine get inside a tunnel of one side, then it want to be come out on the other side. It cannot be get reversed, or it cannot become. It can be stopped at the in between. That is the only problem. If it tunnel is collapsed at in between, then that's all. This tunnel, whatever the tunnel bore machine is, that is collapsed. We want to close the tunnel only. We can't take it back this machine. That is the only disadvantage. Otherwise, then work will be very speedier. This is the penstock, steel penstock, which you are seeing, which is carrying the high pressure water from tunnel to the powerhouse. And this is the one of the small powerhouse, gets 3. This is the from here the penstock comes. You can see, and this is the MIB portion, main inlet wall. This will be automatically open or closed using the control. This is the control room. From here the water comes, and here 2 jets are there. One jet will be here, another jet will it will just start to flow on that turbine, and turbine will be run. This is the horizontal shaft, so turbine will run. This is the generator, and after that from the generator it will take it to the transformer area. And this is the again one type of turbine, this Metro Dam. This is the Uri project horizontal. This is vertical shaft turbine. This is the generator. This is the generator at service bay level. This is the roof figure. We can see the roof. This is underground, not surface. This is the underground power project. This is Tegri. This is the turbine. This is the turbine spiral case. We will have the turbine wheel inside. The water will flow here, and it will rotate, and it will go below. Yeah, here the water will come. It will rotate, and it will go below the draft tube. And this is the rotor. This is the stator where the generator is there. And this is the service of project from Outview during the construction time. And this is again Tegri barrel, generator barrel. And this is the tail race outfall. After everything generated, nothing we can see. Only the water will go inside the tunnel, and only the water can come out of the tunnel. Nothing can be seen at the outside. Everything is inside the hill. So water will come outside here, and it will be joined with your parent header itself. It will be joined with your parent header. That's all from my end. Thanks for listening, and any questions, it's always welcome. I think the presentation went well.
Very good presentation, sir.
If any people have any doubts, then you can come.
Sir, thank you, sir. Thank you for your very good presentation. So first of all,
Thank you. Thank you.
first of all, what I am saying is you are covering entire syllabus of civil engineering units. That is right from
Yes, sir.
second year, third year, and final year. And one more thing, nowadays the dam design will be we are not included in the syllabus because of so many restrictions. So I think your presentation will be highlighted, and also this, but we are put it in elective subject. But many students, unfortunately, they are not offered the subject. I think
Okay.
now you are based on your presentation. I think the third year student here outwards they will take it as one of the elective subjects.
Definitely, sir. Definitely,
That
definitely,
type
sir.
of very informative things will be given, sir.
Okay.
Thank you, sir. Sir, my question is
Yeah.
approximately
Yeah.
for developing or generating 1 megawatt of power, how much quantity of water will be required, sir?
How much power? Water? Sorry, 1 megawatt.
1 megawatt.
1 megawatt. If you see, sir, again it's depend upon the head. 1 minute, sir. I am sharing my screen again. If you don't mind. Yes, I think you're able to see my screen.
Yes,
Sir,
sir.
it is just P. This is a piece of power.
Oh,
So it's depend upon this case. You need Q.
yes,
Okay.
yes,
You need
yes.
a Q.
I know that.
So P I know P is 1 megawatt. That means 1,000. Sorry, 1,000 kilowatt.
Yes,
So
sir.
if 1,000, if I want to put Q is here, I want to take this P. Other thing will become at the subdivision. Okay.
Yes,
So
yes,
P, G, and H everything. Now one thing I want to specify. If Q you want, I want to know H. H is the height of the water flow.
yes, sir.
So if you decide the height of water, whether my height of water will 20 meter or 30 meter or 40 meter, then easily we can find out the Q.
Yes, yes, sir. Yes, sir. So yeah, based on
Yes,
this
sir.
equation, definitely
Based on
we
the equation,
can.
definitely we can get. Only
Yes,
one thing we want to know: if you want to Q, know the Q, you want to finalize first of all H. In
yes,
both Q or H, any one of the parameter I want to know. Because
yes,
Q I will not Q I will specify by using the hydraulics.
yes,
Hydrology. What I will do mostly, what I will do, we will take 10 years, 50 years, 1,000 years, 10,000 years flood. We will calculate by using the probability. Using
oh,
the probability, we will find out what is the river current flow and what is the flow on 50 years before, 10,000 years before, 100 years before. This probability we will find out, and we will find out the discharge of that river. And past 10 years or 20 years data we will collect it, and we will find out the river discharge. So we will find out the river discharge. So Q I found out. I found out the Q. Now I want to check the H. I want to find out the appropriate location where I want to put my power house. So
oh,
accordingly, about the downstream of my river, I will search the location. From that location to this location, I will find out the elevation different, how much it is coming. That is my H. That is my H. So Q is find out from a water, flowing water, and H is there. Now I can find out the power. So
oh,
if a person want to find out the Q, then what he want to first of all, you want to find this, what this is 1,000 megawatt or 10,000 megawatt. I want to power. I want to get the power. Okay, it is ready, and he want to now decide the parameter of height. How much height? 20 meter or 30 meter, 300 meter, 400 meter, where I will get a appropriate place to place my power house. Then
oh,
I can find out the Q, sir. This is interform. One,
yes.
if I want to find out Q, then H is I want to know.
Yeah, yeah. So based on
Yeah,
this equation, we will find out.
yeah, we'll
Yes.
find out, sir. Simple question. Yes, sir.
Sir, my last question is:
Yes.
suppose if the length of the penstock will be increased, whether it affect the your that is your powerhouse will be affected, or if the shorter length will be is a more benefited one.
Sir, length of the penstock, it's entirely affect the economy of the project. That's all.
Oh,
It's
oh,
financial effects. It will not affect the powerhouse area. It will affect only the this one economy of the project. If length increase, the steel quantity increase. Steel quantity increase, my costing is increased. So properly, if I want to plan, shorter length is viable. Shorter length is more flexible for me to complete. But most of the project, what will happen now, sir? While I'm placing my powerhouse, I will finalize my tunnel and I will finalize my powerhouse. In between, I want to connect the penstock. So whatever may be the length, I want to provide it.
mhm,
So that is the cost. Then if I want to reduce, then I want to move my power house
mhm.
towards the hill. If I get a proper location, okay. Otherwise, if I go for underground is costlier. So I can move the power house towards the river and I can increase the length.
I am
So
asking about
increasing in
no, I am asking about
sir.
safety point. I am asking about safety point of view, sir. Suppose if the longer length, whether your that is especially the human life and also the powers, entire things will be safe, or if it go for shorter length, it will be safe.
No, it is not depend upon the penstock length. It is depend upon the penstock where you are providing. No, there the slope stability.
Oh,
There is a slope stability where, which is a very difficult one. As you asked now, yes, it's great. As you are interested, I want to show you an image which was taken last month in a project. I want to show just 1 minute, please. This is in this project is in near Dharmashala. This is a very old project. This is built by our British people. Here, yes. Here you can see this is the penstock. This is the penstock. The penstock length is very shorter. That's not a problem. This where I'm standing. This is the powerhouse. This is the powerhouse. This is the penstock. My whatever here it was. There is a concrete structure. No, that is standard here. No, that is not here. That stands here. This is called 4-way. Now what happened? The slope stability started from this area. This rock broken away and it rolled and it broken this concrete structure and it broken our penstock and it hit my penstock, this powerhouse also. You can see, you can see here, it broken our powerhouse. It came, the total structure came out and it just hit the penstock here, damaged the penstock. Yes, and it damages the powerhouse also. So it's not depend upon the length. It entirely depend upon your slope stability. That is geotechnical person and geological work. If slope is stable, your whole project is stable for a long period. If slope is not stable, definitely we will be lost. And another one more important thing is in south side, if you are making a project, we will be very happy that we will have a stable slope because our rocks are in granite and other things. It's very hard. But if you're doing a project in a Himachal or Nepal, in Himalayan region, mostly in Himalayan region, that's a very young mountain. Mostly this kind of slope stability failures are occurs there, sir. So in lot of the project, making this slope stability is getting more costlier instead of laying this one. So my length of my penstock is not going to affect, only this one, the slope stability, which because for laying this penstock, I want to disturb my parent hill. The hill was not originally like this. The hill was somewhat like this. These people are excavated this one for this one to construct this penstock. They excavated this. So this failure happened from here and it started hitting, sir. So making slope stability is the important one. That will save my powerhouse. That will save my project in a longer term. Yes, sir.
Sir, nowadays the government, Tamil Nadu government, they are encouraged to construct so many check dams across the river, especially to control the flow in rainy season and other things. Whether it is possible to generate under micro system for generating power?
Yes, sir, but only one thing, sir, it is possible in some of the place. Most of the topography in Tamil Nadu, if you see, terrain is very flat. Very flat. So if I put a check dam, it will be a height of 1 to 2 meter or maximum 3 meter. If you see my minimum head, I can head for around 15 meter or 10 meter. If I head, definitely I can make a micro powerhouse like 500 kilowatt or 600 kilowatt. I can make a machine. Normally, I made 2 or 3 powerhouses in Madhya Pradesh. In near to Bhopal, I made 2-3 projects. That's for only 500 kilowatt or something. But there also head we require 10 meter. But if obviously if we had 10 meter head, then we can do it. But if I construct a check dam for 10 meter height, my upstream people know that water will be raised there. They will affect. They will affect. My catchment area will be submerged there. That's the problem.
Thank you, sir. Thank you for your valuable.
Thank you. Thank you. Yeah. Thanks for each and every people who are here to listen my presentation. Thank you very much. Yeah.
A very good presentation, sir.
So good evening to one and all gathered here. So it is my honor to extend a vote of thanks for this online guest lecture. I take this opportunity to thank our management and constant encouragement our principal with the motivation from our vice principal and our beloved HOD. So on behalf of the online guest lecture, we are going to conduct the Department of Civil Engineering in association with ISTE and IEI. Our graceful gratitude our chief guest today, chief guest Mr.S.Arivumani sir, for a Senior Manager and TractebelEngineering Pvt.Ltd, Gurgaon, Haryana, for having taken of this time, many responsibility to join us here and share the oceans with our. Thankful to you, sir. Thank you, sir. I take this opportunity to express our sincere thank to our principal and vice principal for continuous encouragement at every point of time. And I also extend my sincere thank to our HOD sir, Dr. D. Ilango, for his meticulous planning and guidelines. Thank you, sir. And I take this opportunity to extend my most sincere thank to Dr. Limam for guidance throughout to make this event for a great success. And I would like to extend my thank to all the faculty members for their timely helping. Last but not least, I would like to thank budding engineers and entrepreneur of tomorrow for whom this event is organized. So thank you once again. So always wear mask, keep a social distancing, avoid unnecessary traveling, and regularly wash your hands. And I wish you abundance of health and wealth and prosperity. So once again, I would like to thank you all. Thank you, sir.